no one knows the future. Numerous micro and macro factors could alter this trajectory: world wars, pandemics, unimaginable social shifts, or climate disasters. Nevertheless, we're setting off, and we're doing so by discussing the remaining decades of the century we're experiencing right now. Out of all the emerging technologies in the 21st century, artificial intelligence will undoubtedly prove to have the most significant impact. By the 2020s, AI had already reached a level of sophistication comparable to human abilities, both in chatbot conversations and other language models. However, by the mid-century, even more significant developments will lead to social transformations capable of disrupting the lives of billions. For instance, the automation of many traditional jobs will lead to increased technological unemployment and a growing demand for welfare reform, such as guaranteed universal income. The decline in fertility rates and the extension of life expectancy will create an increasing imbalance between employees and retirees. Alongside this, immigration will continue to be a challenge, with an urgent need to attract more foreign workers while controlling the already massive number of economic refugees. In addition to medical advances in reversing biological aging, other noteworthy milestones of this century will include humans landing on Mars and the first detection of a biological signature on an exoplanet. But let's take a closer look at some of the most significant events that, in our opinion, might occur, even though they may not unfold in the exact order or year we indicate in our predictions. 2030. The extremely large telescope is fully operational. Finally completed and inaugurated, this telescope, with its extraordinary 39-meter diameter mirror, will have a far-reaching impact on astronomical knowledge. It's set to revolutionize our understanding even more than the James Webb Space Telescope, which costs 10 times as much. Constructed in the Chilean Andes by the European Southern Observatory, it will possess the power to directly capture images of exoplanets, delve into their atmospheres, and potentially detect signs of water and organic molecules in protoplanetary disks around distant stars. 2031. The International Space Station is deorbited. After entering service in November of 2000, the ISS has gathered significant wear and tear from solar radiation and the relentless effects of extreme temperatures. With its microgravity environment, the station has led to breakthroughs in diverse areas, from medicine and biotechnology to material science. It's been pivotal in monitoring Earth's ecosystems and responding to natural calamities in real time. Plus, it's served as a platform for testing future spacecraft technologies and understanding the long-term impacts of space travel on human health, crucial for paving the way for human exploration of our solar system. 2035. The consumption of lab-grown meat is rapidly gaining traction. As early as the 2020s, strides in the field of biological tissue engineering allowed for the cultivation of synthetic meat from individual animal cells. Following years of refinement and testing, an expansive array of meat-based products is now available, driving a rapidly burgeoning market. Lab-grown meat offers a host of benefits, being produced without inflicting harm or cruelty on animals, and demanding substantially lower quantities of water and energy for production, resulting in a significantly diminished environmental footprint. 2036. In a much-delayed achievement, on July 4, 2036, humans landed on Mars. The Humanity mission, having journeyed for 10 months, remains on the red planet's surface for 3 months before returning to Earth on December 18, 2037. 2037. The global population reaches 9 billion. Throughout most of human history, characterized by often harsh and brief lifespans, the world's population remained under 100 million. However, the modern era has ushered in unprecedented improvements in health, personal incomes, and overall living standards. Remarkably, within slightly more than a century, spanning 1805 to 1925, the number of people on the planet doubled, escalating from 1 to 2 billion. The following billion took only 35 years to attain, with the subsequent billion taking a mere 14 years. Predictions indicate a peak of 11 billion by 2050, followed by a gradual decline. Meanwhile, the planet will have already endured substantial environmental ravages. 2038. airplane accident casualties were reduced to zero. In addition to the substantial growth in passenger numbers, the aviation industry has undergone significant safety improvements. Major airlines are now on the brink of perfecting their flight records, with incidents and casualties nearly eradicated. Passenger aviation deaths reached their peak during the 1970s, with nearly 3,000 fatalities per year. 2041. Fusion power is nearing commercial availability. A prototype commercial fusion reactor is on the verge of becoming operational. Challenges such as containing plasma at high temperatures, maintaining a significant density of reacting ions, and capturing high-energy neutrons without damaging the reactor walls have been addressed. Constructed during the 2030s and early 2040s, the reactor is now close to achieving perfection. In the latter part of this decade, it's expected to generate a consistent output of 2 gigawatts, making the first instance of commercially viable fusion power. 2042. Supercomputers are 1,000 times more powerful than those in 2023. The fastest machines are reaching the speeds of 10 to the power 21 floating point operations per second, drastically reducing the time required for complex astrophysical simulations. This power is instrumental in studying phenomena like black holes, neutron star mergers, and supernova explosions. 2045. A turning point for human-artificial intelligence interactions. This year marks the realization of the so-called technological singularity, postulated by futurist Ray Kurzweil in 2008. Robots have become ubiquitous in all work environments, with humanoid bipedal robots on an exponential rise, particularly within homes and indoor settings. Artificial intelligence, which began merging with human intelligence in the previous century, now surpasses it, reaching entirely new levels of cognitive and intellectual capabilities. High-level decisions by governments and corporations are now predominantly guided by these sentient machines, overseeing extensive virtual staff, robots, and other automated systems. 2049. Establishment of the first permanent lunar base. In the latter half of this decade, government space agencies and private enterprises have created a lasting human presence on the moon. This significant milestone occurs within a period marked by significant technological advancements and a heightened commercialization of space travel. The base, initially dominated by the USA, has evolved into a global village open to all spacefaring nations. 2051. Discovery of life on an exoplanet. Towards the late 2040s, the immense volume of data collected by telescopes, combined with revolutionary methods of analysis, leads to a profound discovery. With the assistance of artificial intelligence and primarily the 39-meter European telescope, conclusive evidence of biological activity on an exoplanet is confirmed for the first time. 2067. The first generation of antimatter-powered spacecraft emerging. These ships utilize tiny specks of matter containing deuterium and tritium, heavy isotopes of hydrogen surrounded by a uranium shell as their fuel. A beam of antiprotons is then fired at these pellets. Upon collision with uranium nuclei, the antiprotons annihilate, generating significant energy that triggers fusion reactions in hydrogen isotopes. With this propulsion system, a journey to Jupiter can be completed in merely 4 months using 1.16 grams of antiprotons. Numerous crewed test missions are conducted throughout the solar system. 2080. Autonomous vehicles dominate the streets. Rapid advancements in artificial intelligence, sensors, and telecommunications have given rise to a new generation of self-driving cars. These vehicles are considerably safer and more reliable than their predecessors, and they now dominate major markets, especially in developed countries. Naturally, road infrastructure undergoes a significant technological acceleration as well. 2090. Religion is fading from European culture. In several European nations, the number of individuals identifying as non-believers has risen from 30% in 1980 to over 90%. In America, the decline in religious sentiment is more moderate but still significant. 2099. Consideration of Mars terraforming. As space travel becomes increasingly cost-effective, now only a few cents per kilogram of payload, and interplanetary journeys are relatively routine, serious plans are underway for the terraformation of Mars, with the ultimate goal of making it habitable for humans. The issue of who should control Mars and its resources became a subject of extensive debates and speculations during this period. 22nd century. In this tumultuous period, developments in space include numerous permanent settlements on the Moon and Mars, regular crew journeys to gas giants, massive asteroid mining operations, and various interstellar probes. Space tourism thrives, and travel to the surfaces of the Moon and other celestial bodies becomes relatively common. During this time, robots play pivotal roles in society in many ways. Some of the most advanced models become so realistic and intelligent that they effectively constitute a new segment of the population, making strides in legal status and gaining personality rights. 2130. Around this time, humans begin to integrate with technology in increasingly sophisticated ways to better interact with artificial intelligence. Highly compact devices become implantable and integrated into the human body, even the brain itself, capable of monitoring and treating diseases, enhancing senses, and providing entertainment or communication in ways that were previously impossible. This new form of bodily enhancement, known as transhumanism, leads to the formation of new social classes. 2132. At the Islamabad Olympics, dozens of world records are shattered. Controversy erupts over the participation of athletes with biotechnological enhancements, the so-called transhumans. 2137. After 22 years of construction, a space elevator connecting Earth's surface to geostationary orbit becomes operational off the coast of French Guiana on a large mobile ocean platform. The entire system is based on positioning a space vehicle in geostationary orbit, 35,786 kilometers above the equator, capable of holding a cable taut extending towards Earth and anchored to the starting station. A cargo lift cabin climbs this cable, capable of carrying many tons of material into orbit at once. Like most transportation forms and infrastructures of the late 21st century, the space elevator is controlled by artificial intelligence, which constantly monitors and maintains the structure. If necessary, robots can be dispatched to solve cable or other component problems, from ground level to the cold void of space. People and goods can be lifted into orbit at significantly reduced costs compared to traditional launches. Over 1,000 tons of material can be raised in a single day, more than the weight of the International Space Station, whose construction took over a decade at the beginning of the century. Although relatively slow, the pace of space travel has become much smoother compared to conventional rockets. Once they leave the atmosphere and reach the desired altitude, goods or passengers can be transferred to a spacecraft. Alternatively, they can continue beyond geosynchronous orbit on vessels moving at speeds sufficient to escape the planet's gravity, heading towards more distant destinations. 2170. By this year, there are dozens of human settlements on the Moon. In the latter half of the 21st century, the advent of low-cost space travel made access to the Moon and its surface relatively easy. Now, nearly 100 years after the arrival of those first colonists, the lunar environment has become a hive of activity, with many settlements mostly built within tunnels carved by lunar volcanic activity millions of years ago. The area affected by these settlements exceeds 7% of the entire lunar surface, and independence movements from Earth are already emerging. 2180. High-tech and automated cities. If someone were to visit a city in 2180, they would be amazed at how clean and organized it is. The air would be as pure as that of the countryside before industrialization. Streets and sidewalks would be immaculate, made from self-cleaning materials that can even repair damage. Buildings, windows, and roofs would be resistant to dirt, bacteria, weather, graffiti, and vandalism. The same protective coatings would be used on public transport and vehicles. Everything in the city would appear new and shiny, always in perfect condition. There would also be plenty of greenery, along with beautiful fountains, sculptures, and other decorations. Streetlights, telegraph poles, signs, barriers, and other visual clutter that once adorned the streets have disappeared. Lighting would be achieved more discreetly using a combination of self-illuminating walls and surfaces. Electricity would be transmitted wirelessly between buildings, and room temperature superconductors would be widely used, allowing vehicles to move rapidly without tracks or cables. 23rd century. Virtual reality and immortality. In the 23rd century, what was once called the Internet has evolved into something much deeper. For many people, it has completely replaced physical reality. Reverse engineering of the brain, combined with advanced nanotechnology, allows human minds to be fully detached and immersed in digital environments. These virtual worlds, capable of existing at speeds far greater than real time, now offer a form of immortality. 2330. With the development of antimatter-powered propulsion, spacecraft can now travel at relativistic speeds, reaching nearby stars in relatively short times. Many deep space missions are now underway, including trips to Earth-like planets within 10 light-years of distance. These small probes are unmanned but commanded by artificial intelligence modules capable of governing all stages of exploration. Given the distances involved, it is believed that the first results will not reach Earth before the end of the 25th century. 2310. By the year 2310, someone calculated that all of Earth's natural energy is now captured and fully exploited. This is the primary requirement for any planetary civilization to be considered a Type 1 civilization on the Kardashev scale. Vast areas of land, sea, and atmosphere have been transformed into a series of massive electrical networks using wind, solar, hydroelectric, and geothermal technologies. In addition to these, fusion and antimatter are harnessed, along with entirely new forms of energy production that were unknown to scientists in previous centuries. 2320. As humanity's focus shifts beyond Earth, a true gold rush is occurring throughout the solar system. Countless technological and engineering marvels are now possible in space, aided by the extensive growth of artificial intelligence that is dominating planetary and interplanetary governance. Massive colonization efforts are currently underway. Asteroid mining dominates the economy of the inner solar system, while hydrogen and helium are extracted from gas giants. Mars terraforming projects are in the works. 2500. Terraforming Mars abandoned. By the year 2500, the World Organization for Solar System Exploration came to the conclusion that terraforming planets like Venus and Mars exceeded the capabilities of current technology. Instead, partial terraforming of the surface is opted for, involving the construction of large domes. Most of the colonists are now cyborgs and transhumans, long adapted to the Martian environment. 2600. Plastic cleanup. Only now plastic and other waste products used since the 20th century are disappearing from Earth's biosphere. These materials caused incredible damage to the environment during their stay on Earth, harming and killing millions of birds, fish, and other animals. 2800. Silent probes. None of the hundreds of probes sent centuries ago to explore extrasolar planets have returned to Earth, nor have any messages been received. 3100. Humanity as a Type 2 civilization. By the year 3100, humanity is becoming a Type 2 civilization on the Kardashev scale. The continuous growth of artificial intelligence has enabled the manipulation of matter on scales previously unimaginable. The largest structure currently under construction in space is a Dyson sphere. This hollow shell is of such immense proportions that it completely encases the sun, capturing all of its solar energy production. Under the direction of an almost godlike superintelligence, vast swarms of automated and self-replicating ships are constructing it, using materials from various asteroid fields and more distant regions such as the Kuiper Belt and the Oort cloud. The inner walls possess a gravitational field of 1G and are made of entirely new states of matter, previously unknown to science. These can withstand the colossal tensile forces required to maintain structural integrity. This incredibly massive curved surface is becoming a habitat for many forms of sentient life, with terraformed sections equipped with atmospheres, oceans, and stable land masses. A significant percentage of the population is now migrating to these strange artificial worlds. This includes a diverse mix of biological humans as well as transhumans, synthetics, clones, androids, sentient animals, and other communities. However, incredibly, still no news arrives from the probe sent to nearby stars in search for life. Humanity seems to have become an omnipotent entity, but as it has done for thousands of years, it can only look at the sky and feel a deep sense of loneliness. 2031 to 2059, the first 10,000 days of the Martian colonization. November 7th, 2031. Two cargo ships separately land on Mars at the two most promising locations for the first human base on Mars, Utopia Planitia and Southern Arcadia Planitia. Both ships have a small nuclear power reactor in cargo and an automatic atmospheric propellant plant to produce oxygen and methane from the Martian atmosphere. The two sites, 400 kilometers apart, were selected on the basis of very restrictive criteria, such as proximity to deposits of water or ice, an intermediate latitude to ensure the contribution of solar heat, and uneven terrain with slopes of less than 5 degrees. After their descent to Mars, in-depth evaluations carried out by two rovers will lead to the final choice of the place where the first human settlement will be implanted, which will provisionally be called Mars Base Alpha. February 2032. After the ground tests are done in both places, the final location of future Mars Base Alpha is selected in Utopia Planitia. 2033. Replenished with propellant derived from the Martian atmosphere, the spaceship that had landed in Arcadia Planitia leaves Mars and returns to Earth in 2035. November 2033. Two other unmanned starships land at the selected location of Mars Base Alpha, a backup ship which has tested the environmental control and life support system on the way, and a cargo ship with rovers, miner, and tunneling droids and solar panels for their first human mission. Several landing fields are also cleared and prepared robotically at Mars Base Alpha location for the human mission next month. 2033. Chinese rover lands on Mars to collect samples and launch them back to Earth. December 25th, 2033. On a mission supported by NASA, two SpaceX crew starships with 12 astronauts each land at Mars Base Alpha, first humans on Mars. The crewed ships, serving as temporary habitats, are accompanied by a few cargo ships, including one with machinery for a ground-based in situ resource utilization system (ISRU), a set of equipment that collects, processes, stores, and uses the material that a planet makes available. 2033. NASA's Research Mars Surface Field Station is established at Mars Base Alpha, a complex of modules used as research centers to coordinate the first wave of Martian exploration. 2034. Solar array is built at Mars Base Alpha to supplement the energy generated by nuclear reactor on board the first cargo starship. 2035. Several space agencies join NASA in financing the scientific operations at Mars Base Alpha and transport of their scientists between Earth and Mars. 2035. Two constellations of Starlink satellites with a global positioning system and a global communication system are deployed around Mars. Now, it's hard to get lost on Mars, possibly only in a lava tube or a narrow canyon. 2035. Mining of water ice starts near Mars Base Alpha, a ground-based system with an atmosphere separator and chemical propellant plant capable to produce and store water, nitrogen, argon, and liquid methane, and oxygen is assembled. 2036. Several landing and launch pads for future Starship missions are built a few kilometers from Mars Base Alpha. 2036. Martian regolith extraction, chemical separation, and storage equipment is assembled. The useful elements can now be used in the greenhouse and ISRU system. 2036. Second crew of 30 astronauts and workers aboard a Starship lands at Mars Base Alpha. The first modular ground habitat and a hydroponic greenhouse are built to provide Mars Base Alpha with locally grown vegan food. 2037. Some of the landed cargo starships and one crew starship with a small crew and some returning scientists leave Mars. Their arrival on Earth is expected after 8 months. 2038. First fully occupied starship with 50 scientists, workers, and colonists land at Mars Base Alpha. 2039. NASA's Mars Surface Field Station is reorganized into an international scientific research base with scientist crews rotating every Earth-Mars synod, 26 months. 2040. The ISRU capabilities of Mars Base Alpha are extended not only to produce air, water, and methalox fuel, but also steel, bricks, cement, basic fertilizers, plastics, and silica products, as glass panels. Some industrial-sized 3D printers are also assembled. 2040. First orbital fuel depot for Hydrolox and Methalox rocket engines completed at low Earth orbit. The hydrogen and oxygen are provided from the Moon and near-Earth asteroids, the methane from Earth. 2040. The International Mars Surface Field Station officially declares that Mars does not host indigenous life forms. June 2040. A large amount of cyanobacteria is introduced into the ISRU processes of Mars Base Alpha. We can say that this is the beginning of the terraforming of Mars. July 2040. A fish farm is built at Mars Base Alpha to provide more diverse local food for the colonists. The greenhouse is vastly expanded. 2040. Starships with 97 human colonists and workers land at Mars Base Alpha, which now has a population of around 170. Cargo ships bring in heavy-duty construction and tunneling equipment. 2042. A transparent, radiation-filtering geodesic dome with a garden is built at Mars Base Alpha. Work begins to build a new underground section with larger habitats and working areas to boost the population capacity of the base to at least 1,000 inhabitants. February 2042. First baby born on Mars. It's a girl, the daughter of 2 NASA scientists. Her name is Noise Lambent. Controversies erupt on Earth over the child's likely inability to return to her home planet one day. The Martian colonists reply that by now her home planet is Mars. July 2042. Starships with 223 human colonists, workers, and individually wealthy tourists land at Mars Base Alpha. November 2042. First votes to elect an official representative of the Martian colonists. It will remain in charge for an entire Martian year, equal to 668.6 Sol or 680 Earth days. 2042. First expedition to the summit of Olympus Mons, the tallest planetary mountain in the solar system. During the ascent, the first fatal accident occurs. One of the members of the expedition loses their life sliding on a steep escarpment. 2043. Several small proxy bases for scientific, mining, and other purposes are established within a few tens of kilometers from Mars City. March 2043. Mars Base Alpha changes name. A quick referendum among the 400 settlers decides that provisionally the settlement will be called Mars City. 2043. The new underground section of Mars City is finished. Now the colonists have a lot of spacious living and working quarters with full radiation protection. 2043. Cultured meat farm is built, adding meat, although artificial, to the diet of the colonists. 2043. Virgin Galactic Company establishes the first luxury hotel on the outskirts of Mars City. 2044. On behalf of several space agencies and asteroid mining companies, a Blue Origin manned spaceship reaches Phobos, with the first modules to make the free spaceport of Phobos, intended to serve as a station and fuel depot and repairs for manned and unmanned spaceships to Mars, to the asteroid belt, and beyond. August 2044. Starships with 300 passengers land at Mars City, which now has a population of around 770. Among them, the now 73-year-old Elon Musk, who crowns his desire to go and die on Mars. 2045. Large deposits of minerals with a high concentration of rare metals are discovered a few hundred kilometers from Mars City. A research mining base, Beta, is established. 2045. Robotic water ice mining station is built on Phobos to supply the water and propellant needs of nearby free spaceport. 2045. A land trip all around Mars is completed for the first time. 2045. The landing pads near Mars City, where crew and cargo starships have landed and taken off for 14 years, are transformed into a small spaceport with pressurized sky bridges for both passengers and cargo. It includes several ports also for the newly developed Heavy Starship, the next generation of Starship system with a core diameter of 18 meters, more spacious living quarters for up to 200 passengers, and spin artificial gravity of 0.38 g, the same of Mars, when in duo ship mode. 2046. First two Heavy Starships, each with 400 passengers, land at the spaceport of Mars City. Cargo Heavy Starships bring parts for a nuclear fusion reactor. 2046. With additional modules arriving and maintained by Blue Origin, the International Free Spaceport of Phobos is now operational. Robotic asteroid mining in main asteroid belt can now rapidly expand. 2046. Blue Origin's lander lands on Mars for a scouting mission to confirm the best location for a Blue Mars base. 2046. First school opens in Mars City. Now it is allowed for children over 14 years to travel to Mars along with their parents. 2047. A public transport route between Mars City and mining base Beta is established. 2047. A short Hyperloop line from Mars base Alpha to its spaceport is finished. 2048. Two Heavy Starships with 400 passengers land at Mars City, and another one with 200, mostly miners, at the mining base Beta. The population of the Mars base Alpha now surpasses 1,200, with 200 more colonists living at nearby proxy bases and 300 at mining base Beta. 2048. Blue Origin's spaceship fleet with 100 workers arrives at Free Spaceport of Phobos. Workers are shuttled down to establish the Blue Mars base about 1,000 kilometers from Mars City. 2049. A nuclear fusion power station is operational at Mars City. 2049. A new underground section of Mars City is finished, boosting its population capacity to 3,000. 2050. With increased electrical power, the industrial capabilities of Mars City are greatly extended, using the resources harvested, refined, and processed around the city and nearby proxy bases. Solar panel assembly factory is the first factory on Mars manufacturing complex products. Start the Mars economy. 2050. Mars City Police Force established, taking over the policing function in the region from security guards hired by SpaceX. January 26, 2051. Closest approaches of Mars to Earth since the beginning of the colonization. The largest colonial fleet ever arrives at Mars with 100 colonists landing at Mars City, 200 at mining base Beta, and 200 at Blue Mars base. 2051. With China and Russia focusing on the moon, India is the first Asian superpower to establish its own base on Mars. 2052. An international human mission to Ceres, flying with a new generation nuclear fusion spaceship, stops at Free Spaceport of Phobos to resupply, drop some scientists at Mars City, and take additional crew members from Mars. 2053. 1,200 colonists land at Mars City and mining base Beta, and 150 at Blue Mars base. There are now more than 4,000 humans permanently or temporarily living on the surface of Mars. 2053. At an impact crater near Mars City, work begins to build the first large-scale dome on Mars, covering the entire crater more than a kilometer across. 2055. Several more Blue Origin's shuttles land at Blue Mars base, boosting its population to more than 500. Indian Mars colony now has more than 200. 2055. Using its strong presence on the moon in its favor, China also established its own colony on Mars, which now is being expanded fast. 2056. First public suborbital shuttle route between Mars City and Blue Mars base is established. 2056. The large-scale, transparent, radiation-filtering lightweight dome is finished and pressurized near Mars City. It covers an area of almost a square kilometer. Workers move in now to construct the buildings and gardens with such features as artificial waterfalls below the dome. 2057. New generation of SpaceX's nuclear fusion-powered spaceships arrive at Free Spaceport of Phobos. Passengers are shuttled down to the spaceports of Mars City and Mining Base Beta. Old starships and heavy starships are retired from SpaceX's fleet after 36 years of successful service and sold to several interested countries and companies. 2058. The interior infrastructure of Mars City's dome is finished, having a maximum population capacity of 20,000. 2058. A Hyperloop line and heavy cargo train tracks are built between the Mars City and the industrial complex at Mining Base Beta. 2059. SpaceX's nuclear spaceships take more colonists to Mars City, bringing its population to more than 6,000. 2059. First Brazilian heavy starship lands at Mars City. One of the nearby proxy bases is sold to Brazil and expanded with more living habitats. 2059. The United Arab Emirates establishes its first base on Mars, the new Dubai. March 25, 2059. In Mars City, in one of SpaceX's residential domes, Elon Musk dies suddenly at the age of 88. Exactly 10,000 Earth days have passed since November 7, 2031, the date the first starships landed on Mars, starting the colonization. The year is 2123, and humanity has done the impossible. After a century of drifting through the void, the starship Helianthus has delivered its people to Proxima Centauri b, a world that was only ever a distant dream. 7 generations were born, lived, and died aboard the ship, never touching soil, never feeling wind. Now their descendants step onto alien ground for the first time. But this planet is not Earth. The sky is a dim crimson, the air is poison, and gravity itself is an unseen enemy. The next 10,000 days will test what it truly means to be human. Will they build a future here, or will the ghosts of their ancestors have died in vain? And when survival demands sacrifice, how much of our humanity do we dare to lose? Let's find out. 100 years. That's how long it took for the Helianthus to reach Proxima Centauri b. As the massive spacecraft slips into orbit around this exoplanet, the colonists gather on the observation decks, their eyes glued to the alien world below. It is smaller than Earth, with a surface that looks like a mix of rocky plains and glimmers of ice. They face a tough choice: settle in the twilight zone, that narrow strip between extremes, or take their chances in the planet's harsh environment. The moment is both exhilarating and terrifying. First contact. The first shuttle makes its descent towards the surface of Proxima Centauri b. The landing is turbulent, with the planet's stronger gravity pulling relentlessly on the colonists' bodies. The shuttle finally touches down on a barren rocky plain near the equator, a location carefully chosen for its stable temperatures and access to subsurface ice. The atmosphere is dangerously thin and laced with toxic gases, carbon dioxide, methane, and sulfur, making it impossible to breathe without advanced spacesuits. As soon as they land, the team of scientists, engineers, and life support specialists springs into action. Prefabricated habitats are deployed, and a compact nuclear fusion reactor is activated to power the colony. Water recycled for a century aboard the Helianthus is extracted and purified. But even as the first structures rise from the alien soil, the colonists face a harsh reality. This world is not designed for them. 55 days after arrival, the stronger gravity starts taking its toll. Colonists grow shorter, their bones denser, and their muscles stronger. But the physical changes come at a cost. Fatigue is constant and injuries are common. Then comes the first signs of a mild yet mysterious illness, Proxima lung. Triggered by microscopic trace elements in the planet's atmosphere, the illness affects the respiratory systems of the colonists. Medical teams scramble to find a cure, but the sickness is a little reminder of how alien this world truly is. Amid the struggle, a dark joke circulates among the colonists. What if Earth sent a faster ship? The idea that Earth might have deployed faster than light travel and beaten them to Proxima Centauri b is both a hope and a fear. Early survival and adaptation. Something feels off. The colonists sense it from the moment they arrive. There is no sunrise, no sunset, only an endless half-light stretching across the horizon. Proxima Centauri b is tidally locked, meaning one side is forever ablaze under a merciless red sun, while the other is drowned in unending night. Step too far in either direction, and you risk either burning or freezing. The settlement clings to the twilight zone, the only region where survival is possible. To cope, the colonists created artificial cycles. Inside their habitats, controlled lighting and schedules simulated a 24-hour day. Work shifts, meal times, and sleep periods were carefully regulated to mimic life on Earth. But outside, the environment remained alien and unyielding. The psychological impact was profound. Some colonists struggled with insomnia or depression, while others felt a deep sense of dislocation as if they were living in a dream. Now it's day 100. The colony is taking shape. 4,538 colonists have made planetfall, while a small crew remains aboard the Helianthus. Water extraction becomes a priority. Using electrolysis, the colonists split water molecules into oxygen and hydrogen, ensuring a steady supply of breathable air and fuel. Underground ice deposits are tapped, providing a crucial resource for drinking and irrigation. Food production begins in biodomes, where genetically modified crops are cultivated under controlled conditions. Wheat, rice, and legumes are engineered to thrive in the low light and high radiation of Proxima Centauri b. But the challenges are far from over. The stronger gravity makes farming labor-intensive, and the colonists must adapt their techniques to the alien environment. Medical teams work tirelessly to help colonists adjust. Light therapy and melatonin supplements are introduced to simulate Earth's day-night cycle, while physical therapy programs help combat the effects of the planet's gravity. But the psychological toll is harder to address. The unchanging twilight, the constant hum of machinery, and the ever-present threat of solar flares weigh heavily on the colonists' minds. As the colony expanded, so did the discussion around genetic engineering. With the original settlers having limited genetic diversity, the risk of inbreeding was a real concern. Genetic counseling became a must, and they began using cryogenically stored genetic material from Earth to introduce new traits. The hottest topic, though, was gene editing. Some believe the colony's survival hinged on boosting the next generation, making them stronger, more radiation-resistant, and better suited to the planet's gravity. Others were worried about the ethical side of playing God. The debate hit a turning point with the birth of the first human on Proxima Centauri b. Named Ava, she became a beacon of hope for the colony's future. But her arrival also sparked tough questions. Would she and others like her be the first of a new species forever altered by their alien home? Or would they stay human, tied to the legacy of Earth? Scientific discoveries and expansion. It's officially day 212, and the colony is finally stable. With the basics under control, scientific exploration is taking center stage. Soil samples reveal a complex ecosystem of microbial life, sparking debates about whether Proxima Centauri b could one day be terraformed, or if unknown pathogens could pose a serious threat. Geological surveys uncover rich veins of superalloys, perfect for construction and energy production. Meanwhile, geothermal activity offers a new power source, and volcanic regions promise valuable minerals. The first human birth on Proxima Centauri b marks a turning point for the colony. Ava's arrival is a moment of celebration, proof that life can truly take root in this alien world. But it also raises big questions. The colony isn't just a settlement anymore, it's becoming a society, with all the challenges and complexities that come with it. By the end of the first year, the population has grown to over 5,000. Vertical farming towers rise like futuristic monuments, sustaining the colony with carefully engineered ecosystems. Scientists develop pharmaceuticals from native compounds, unlocking new treatments for Proxima-related illnesses. Above, the Helianthus still orbits, serving as a research station studying the planet's atmosphere and the neighboring stars. But even as the colony celebrates its successes, new obstacles emerge. The planet's 11-day orbit and elliptical shape create unpredictable seasons, shifting wind patterns and intensifying storms. Solar flares remain a constant danger, forcing colonists to reinforce radiation shielding across all structures. And the biggest debate of all, whether to adapt to the planet or change it through terraforming, grows more heated by the day. Long-term growth and cultural shifts. With the colony's growth come bigger ambitions. New technologies emerge, driven by the need to survive and thrive on Proxima Centauri b. Radiation shielding becomes a top priority, and engineers race to develop lightweight, super-strong materials using the planet's minerals. Vertical farming towers expand, supporting entire ecosystems that provide food, medicine, and even glowing plants for lighting. The debate over terraforming heats up. One faction argues that the colony should adapt, embracing the planet's unique conditions and learning to live in harmony with its environment. The other side pushes for terraforming, convinced that reshaping the planet to resemble Earth is the key to long-term survival. The stakes couldn't be higher. Terraforming would take massive resources and come with unknown risks, but it could make the planet far more hospitable for future generations. At the same time, genetic policies come under scrutiny. With a limited gene pool among the original settlers, the risk of inbreeding and genetic disorders looms large. Strict guidelines are put in place to maintain diversity, and cryogenically stored genetic material from Earth is introduced to strengthen the population. Advanced gene editing techniques eliminate hereditary diseases and enhance resilience to Proxima's harsh conditions. But these breakthroughs spark some cultural transformation that very few would have expected. William Golding once said in The Lord of the Flies, "The greatest ideas are the simplest." This couldn't be more accurate when it comes to the cultural shifts in this new society. Over time, the colony develops its own culture and traditions. A new calendar system is created based on Proxima Centauri b's 11-day orbit. The centennial celebration, held every 100 cycles, about 3 Earth years, becomes a major event marking the colony's progress and honoring those who have sacrificed to build it. The Twilight Vigil, held every 33 cycles, about 1 Earth year, celebrates the colony's unique position in the Twilight Zone with bioluminescent displays symbolizing the life they have brought to this alien world. But not all is harmonious. As the population grows, so do tensions. The debate over terraforming divides the colony, with some advocating for radical change and others calling for caution. Rising conflicts over resources and governance test the colonists' unity. Yet, despite these challenges, the colony continues to evolve, driven by a shared determination to survive and thrive. First contact, but not how they expected. About 5,922 days after landing, the colony makes a startling discovery. Astronomers on board the Helianthus detect strange gravitational anomalies in the Proxima Centauri system. Further analysis reveals previously unknown asteroid belts and fluctuations in the gravitational interactions between the 3 stars. The discovery raises an intriguing possibility. Could there be other forms of life in the system? A small probe is launched towards Proxima Centauri c, the outermost planet in the system. The journey will take several years, but the data it sends back could revolutionize the colony's understanding of its new home. Some colonists speculate that the anomalies might be evidence of extraterrestrial intelligence. Others dismiss the idea as wishful thinking. But the possibility of first contact, real contact, looms large in the colonists' minds. As the colony nears its 27th anniversary, it finds itself at a critical crossroads. The population has swelled to 8,000, with nearly half of them born on Proxima Centauri b. These planet-born individuals are shorter, have denser bones, and boast enhanced low-light vision, a clear sign of the colony adapting to its new environment. However, they also face unique challenges, including new illnesses like Proxima lung. The future of the colony is filled with both promise and uncertainty. Big plans are in the works, such as constructing an artificial lake and expanding mining operations. Engineers dream of building long-range spacecraft to explore Proxima Centauri c and beyond. The Helianthus, still orbiting overhead, remains a symbol of the colony's beginnings and its potential. Some believe that the great ships will one day launch again, taking a new generation of pioneers to another star. But the big question lingers. What kind of future will the colonists build? Will they continue to adapt to Proxima Centauri b, embracing its challenges and opportunities? Or will they try to reshape the planet, making it more like the Earth they left behind? The answer will not only shape the colony's destiny, but also the future of humanity itself. But here's a question most colonists never stop to ask. Wouldn't terraforming Mars be a much easier option? Trust us, this is the journey you don't want to skip.